In today's lesson video, we're going to be taking a look at day 4.3, and we're going to be talking about triangle similarity, specifically triangles. Last lesson, we talked about similar polygons and what it means for polygons to be similar. Today, we're specifically looking just at triangles. And triangle similarity, again, polygons are similar if all the angles that are corresponding are congruent and all the sides that are corresponding are proportional. Well, when it comes to triangles, because of what we've talked about before with something called triangle rigidity, we can actually use some shortcuts to establish that triangles are similar based on some more specific information. So in this example, where we have these two triangles here, I've marked two angles congruent, but then I've also got these vertical angles that are congruent, like that. So there's two pairs of angles that are congruent. And actually that would mean that these third pairs of angles here would have to be congruent as well, since all three angles of a triangle add up to 180. So really all three angles of one triangle are congruent to all three angles of another. That makes the triangles have to be similar. And so here's what we have for our first similarity theorem, and that is angle-angle similarity. That symbol means similar again, okay? And here's what angle-angle similarity states. If two angles of a triangle are congruent to two angles of another triangle, then the triangles have to be similar. So this is kind of like we had side-side-side congruence and those kind of things for congruent triangles. For similar triangles, the first one we talk about is just angle-angle, because it takes two angles of one congruent to two angles of another for the triangles to be similar. Then because of this, reasons a lot like that, when we talk about similar triangles, we could establish what is called side-side-side similarity. All right, and that states this. If three sides of a triangle are proportional, okay, not equal, but proportional to their three corresponding sides of another triangle, then the triangles are similar. And here's what that means. The sides that go, again, the order of the side lengths is very important. QP is 3, that's the shortest side. That ratio to the other shortest side would be 3:6. The middle side length would be 4 for the smaller triangle and 8 for the larger triangle. And then the longest sides of each one are 5 and 10. Those are all equal ratios. Those would all simplify to the ratio 1/2. So all three sides of the smaller triangle are proportional to their corresponding sides in the larger triangle, because they all work out in a 1:2 ratio. That means these triangles have to be similar. Even if I don't know any of the angles, if I can show side-side-side similarity with proportional side lengths, the triangles have to be similar. Okay? We've got one other theorem to discuss, and that is SAS, which you probably understand means side angle side, which states this. If two sides of a triangle are proportional to two corresponding sides of another triangle and their included angles are congruent, then the triangles are similar. So here's what that looks like for this one. We have the shorter of the two sides given here as 8. Its corresponding side on the other triangle would be a 6. That ratio is going to have to be the same ratio as the longer side, 20, over its corresponding side, 15. And those would actually be equal, because if I reduce each of those fractions, I get the same thing. First fraction, we can divide both by 2, giving us 4/3. When we look at this second fraction, 20 over 15, that also reduces to 4/3, because you could divide both of them by 5. 20 divided by 5 is 4, 15 divided by 5 is 3. So the two sides of the bigger triangle are proportional to two sides of the smaller triangle, and then the included angles between them, that's these, because they're between the two sides that are marked, those are congruent angles because they're just given to you that way. So that makes these triangles similar by side angle side. So as we begin this, there's some things you need to understand. To prove similar sides or proportional sides, you need to set up a proportion and see if the measurements are proportional by finding the scale factor. Let me fill all this in for you. Okay. Actually, the first word is ratios. We're going to set up ratios of corresponding sides to see if the measurements are proportional by finding the scale factor. They must be proportional in order to be similar for comparing sides. But to prove angles are congruent, there's a lot of different ways we could do that. Okay, you may use what we call a common angle if the two triangles share an angle, or the reflexive property is another thing we said there. That was our other thing we could use. You could use marked angles or vertical angles that are congruent. If you're given parallel lines, you could use corresponding angles. Or you could use alternate interior angles. Okay? If you're given two angles, you could use the sum of the interior angles, adding up to 180, to find the third angle as well. Okay, so you can use some calculations there by remembering all three angles add up to 180. So as we move on, let's take a look at our examples. Okay, we want to determine similarity. We are trying to figure out, are they similar or not? We're going to circle yes or no. And if yes, we have to be able to use either AA for angle-angle similarity, or SSS for side-side-side, or side-angle-side. Okay, so in these examples, we're going to determine if they are similar triangles. If they are similar, we're going to justify it by showing work and establishing which of these similarity theorems we can use. And we're going to write a similarity statement. That's the last part here, and it is really important that we do that. Okay, we're going to write a similarity statement. Triangle ABC is similar to the other triangle. Excuse me. As we look at number one, okay, it looks as if we're trying to use side angle side. Don't just assume that that's what we're using and say that that answer is yes. Side angle side states that two sides of one triangle must be proportional to two sides of another triangle. So we're going to check the ratios of corresponding sides. So as I compare one of these sides, let's start with a 3. I'm going to compare it to the corresponding side, which would be the smaller of the other two, 9. And I'm going to see if that is equivalent to the other ratio of corresponding sides. It would have to be 5/15. Okay, the smallest over the other smallest, biggest over the other biggest. Well, 3/9 and 5/15 can both reduce to the fraction 1/3. 3/9, divide both by 3, you get 1/3. 5/15, divide both by 5, and you get 1/3. So the sides are proportional, and we have marked angles that are congruent, that are the included angles. So yes, these are similar by side angle side, but I'm going to write the similarity statement using the appropriate order of letters. So the first triangle I'm going to call triangle EFG. Has to be similar to triangle. Now be careful how you do this. Since F is the middle angle of the first label, it's congruent to angle T in the other triangle, so that must be the middle letter in that label. And EF corresponds to RT, so that means that the other triangle has to be called RTS. Okay? So we're going to do a few more of these. The video won't cover every one of them. As we did in the last video, I'll do some of them with you in the video, and then at the end of the video, I will display the answers for the rest. That way, if you want to try them on your own, you can. So as we look at number 2, okay, we've got only angles given. That means I should be using angle-angle similarity to show these triangles are similar if they are in fact similar. But if I just look at it at its face value, it looks like it's not enough information or not the right information. We do have vertical angles that are congruent, and they tell you that that angle is 42. So I'm going to go ahead and write in that this is 42 degrees. But then the other two angles don't look like they're congruent. They're not. We have a 53-degree angle and an 85-degree angle. However, we need to write these other two angles in to see if maybe either one of those is congruent to the 85 or the 53. So if I were to add these two together, 42 plus 53, that gives me 95. So these two add up to a total of 95 degrees. And to find the third angle here, we're going to do 180 minus that 95. And if you do that subtraction, that's 85. So instead of unknown, we know that angle is 85 degrees. Now angle E is congruent to angle C because they have the same measures. That makes these triangles similar by angle, because I have two pairs of congruent angles. So yes, these are similar by angle, and then your symbol for similarity. And then we want to write the similarity statement. Okay, so we're going to start with one triangle. I'm going to start with the one on the left. I'll call it triangle A, B, E. That must be similar to, now B has to be the middle letter of both labels. And since E was congruent to angle C, that means A is going to end up being congruent to angle D. So the other triangle is called triangle DBC. Okay. All right, we're going to skip number 3 for now. We're going to go down and take a look at number 4. All right, on number 4, we've got two triangles, but you want to be careful when we are using these overlapping triangles. We do have two triangles that share a side, share an angle. Okay, they share angle D. So there's the bigger triangle. Here's the smaller triangle. And so we want to establish what makes them similar. In order for them to be similar, I either have to use angle similarity, side angle side, or side side side. Well, I don't have these side lengths, so I probably can't do side side side. But I do have matching sides on the left and the right, and the two triangles share an angle. So I'm probably going to use side angle side, but I have to check the proportionality of their side lengths. So I'm going to set up my first ratio as little side length, or side length from the littler triangle, over its corresponding side of the bigger triangle. The other number I have to use is the sum of these two lengths then, 44. Okay, the other one of these I want to do would be the smaller length 35 over its total side 65. And I want to try and see if those are reduced to the same value. Now, you could do it that way, or you could cross multiply and see if the cross products are equal. Okay, but the numbers are kind of large, so this time we'll go ahead and just try and simplify the fractions. 24 over 44, I know I could divide by 2. Okay, that would give me 12 over 22. I can still divide by 2 again, giving me 6 over 11. All right. Now I want to see if 35 over 65 reduces to the same thing. Since they both end in 5s, I know I can divide by 5. 35 divided by 5 is 7, and 65 divided by 5 is 13. Now those cannot be reduced any further. These are not equal to one another, so my answer is no. These are not similar. So there's nothing else to write. When your answer is no, your work has backed that up. Okay? All right, number 5, it looks like there's just not much information given. You need to remember these markings are not congruent markings. They are, parallel line markings. Remember, parallel lines create either alternate interior angles that are congruent or corresponding angles that are congruent. And I'm going to use the corresponding angles here to show those are congruent angles, and here to show those are congruent angles. So I've got angle similarity. I've shown two pairs of congruent angles. So yes, these are similar by angle similarity. So one triangle for my similarity statement, I could call triangle LKM. It would have to be similar to the triangle KJN. Okay? So that's how we can practice using some of these. There's quite a few more here. I'm going to show you those examples. If you want to try them on your own, that's fine. I'm going to show you one more example actually before I get going. Number 7. Number 7, there's no angles given. They're not overlapping. They don't share an angle. There's no marked congruent angles. There's no vertical angles. So probably we're trying to set this up to use side, side, side. in order to do that, we want to show the proportionality of all corresponding side pairs. So I'm going to start with one side from one of the triangles. Let's use the smallest side from this big triangle, 22, and compare that to the smallest side of the other triangle, which would be the 16. Okay. The other pairs of matching sides, if I went to the middle side or the middle side length, 28, it corresponds to the middle side length 20 on the other triangle. And then finally, the largest sides are 35 and 25. And so I want to match those up and I want to see if these are actually equal. So I want to reduce each one of these. 22 over 16, we can divide by 2. That's 11 over 8. Can't reduce that anymore because 11 is a prime number. Probably not going to work out this time because the other numbers aren't divisible by 11. But I'll double check to show. If on 28 and 20, we could actually divide both of those by 4, which gives me 7 over 5, already not equal, so I know my answer is going to be no. The other two do work out to be 7 over 5 as well, but all 3 sides would need to be proportional to the other 3 sides. So because of this, these are not similar. All right, like I said, the other examples I'll give you answers for at the end of the video. Otherwise, we want to move on. Sorry, that is the end of the video, okay? So that kind of concludes all the examples I'm going to show. If you want to pause the video here and try the other problems on your own, you're welcome to. Otherwise, you'll just kind of skip past these answers I show. All right, these are the answers you should get on 3, 6, 8, and 9. For number 3, you write out all of these ratios and they all do reduce to the same equal proportion or equal ratio of 3/4. So yes, these are similar by side, side, side because all 3 sides of the smaller triangle are proportional to the 3 sides of the bigger triangle. Okay, number 6, because we have these parallel lines, we have alternate interior angles here and here, which are 2 pairs of corresponding congruent angles. So these are similar by angle, angle. And number 8 here, these are again similar because of angle, angle, because we have a common angle, and then we also have the corresponding angles there, or even the angles at C and I are congruent as well. So these are similar by angle, angle similarity. And then lastly, number 9, these are not similar, and here's how I know this. When I find the other angle measure for y here, it ends up being 29 degrees. I subtract 90 and 61 from 180, I get 29. That is not equal to 34. Okay, and 61 is not equal to 34. So there aren't going to be 2 pairs of congruent angles. The only congruent angles are the right angles, Z and G. So these are not similar because they don't have the right angle measures.